Okay, I believe it's sharing. Let's see if we can get it to change slides. Yes. There we go. So again, I focus my work on digital engineering, in particular model-based systems engineering, which Nkosi has defined and has identified numerous benefits for. The reality is that more and more we're seeing here in the United States, at least, that customers are calling for digital engineering, right? In 2018, we had the DoD release their digital engineering strategy. Roughly 2 years later, we saw all of the military forces individually release a strategy, and there's this continued emphasis on MBSE and digital engineering appearing more and more prevalent. And it's mostly because the complexity of systems and the complexity of developing those systems is increasing. So a philosophical approach in entering into this work was what we like to refer to as MBSE 2.0, right? Historically, MBSE 1.0 is diagram-centric, right? Well-intentioned, but a bit flawed in the sense that we're trying to use very expensive tools like Cameo or Rhapsody to produce pictures instead of producing data. You know, at the end of the day, these MBSE tools are really about building, you know, an underlying relational database that connects the data with other pieces of data via important relationships. And it's not until we switch our mindset to think like this are we really going to realize the full potential of MBSE and digital engineering as a whole. So the problem we were trying to solve when we entered into doing this work was, again, system complexity is increasing and there's a greater number of organizations that are being asked to contribute to the architecture and design of systems. We're seeing an emerging pattern of individual systems no longer necessarily being the focus, but rather their integration in order to form larger system of systems. It's the connectivity of systems developed by different organizations, in fact, that is becoming emergent pattern, right, within the industry. And we really need a digital engineering solution that allows for this, right, that supports, you know, the independent standalone models for systems that can then come together in order to describe the larger system of systems problem and solution. And in doing so, we need to keep a few things in mind. Not everybody uses these models the same way, so there's a style difference across the board. You know, there's intellectual property rights or other types of protected data that needs to be kept in the forefront of our mind such that we don't violate people's rights. And then, of course, there's the ever-enduring concept of authoritative sources of truth, right? We do not want to write one thing down in two places, right, continuously. So what do I mean when I say system of systems? Okay, so historically, the literature looks at these 5 basic criteria that are, you know, ubiquitously common across systems of systems. But when I'm using this term in the context of this presentation, what I'm really talking about is managerial independence, right? The constituent systems need to be sufficiently complex to warrant architecture models of their own right and are managed by different organizations, okay? If you are one company, one team that's building all of the systems within your system of systems, this may not be the best approach for you. So there's a whole bunch of examples on the screen of different systems that apply, right? But I'm going to use the combat system graphic at the top in order to, you know, tinker at this a little bit because at my heart, I'm a combat systems engineer. So a combat system is generally composed of 3 main pieces, right? A sensor, one or more of them, command control, and then one or more weapon, right? And then usually there's some sort of systems integrator required in order to connect all of those things together. So just right there, right, in the world's most simple combat system, you've got 3 constituent systems that all have to come together in a fairly complex way in order to actually meet the overarching mission goal, right? That's the pattern I'm talking about, right? When applying this is, you know, where a sensor is sufficiently complicated to allow for a developer in his own right to build an architecture model and own that architecture, but yet it needs to be participating in a larger system of systems that includes, in this case, command control and weapons. Okay, so, you know, we don't want to be foolish in ignoring the lessons of the past, right? So for my research, I found 3 primary categories of previous approaches. And the first is no doubt the most common, which is independent architecture models for each system, right, within the larger system of systems. And the trouble here is that you're not addressing system of systems concerns whatsoever, right? These individual models are built in different ways by different people and then generally not connected in any digital engineering sense of the term. So who's to say that they actually will come together and integrate? Right? The second approach, which I've personally participated in my career, is the integrated approach, where you use a single monolithic system, one system model to rule them all, if you will, right? And that creates all sorts of issues when you're talking about geographically diverse teams from different organizations. Everybody can't work literally in the same model, in the same project, within the same teamwork cloud environment all of the time. It's too tightly coupled, right, to support these larger system of systems development problems. And it makes it difficult to incorporate changes and low-level details that really don't impact other systems within the system of systems. And then the third, and maybe most controversial in some ways, approach is to use some sort of framework-based approach, right? Anymore, we hear UAF all the time as kind of the new trendy guy on the scene. But at the end of the day, in my limited experience, a lot of these frameworks tend to create a checklist mentality where folks are building out viewpoints or views just because somebody prescribed them. And then often there's still no connectivity to individual system models, right? There's also a pretty large learning curve associated with some of these unique architecture frameworks when applied within MBSE model. 200 plus distinct customizations layered on top of SysML is a pretty challenging thing to get someone to learn, let alone a large organization or multiple organizations of people. So our general solution to this is a federation-based approach, okay? The idea is to encourage a loose coupling of models through project usages, right? Where each one of these teal bubbles you see on the screen represents an individual standalone model, right? But the dotted lines show project usages, allowing lower level models within the stack allowing higher level models within the stack to leverage the content of those that are lower with, okay? This permits various system models to be developed by different organizations and allows the system of systems level, right, to describe the structure and behavior of that system of systems, not in an original sense, but based on reusing the content from the peer level system models, as well as fundamentally the common library reusable content, right? This approach can be adapted to offer protections for intellectual property and other kinds of protected data, and also two birds with one stone, if you will, can be adapted to allow for model style diversity, right? And we'll get to that again here a little bit later in the talk. But the idea is to support the contributions from multiple groups and allow them to collaborate where they need to in order to come together and make that system of systems description. It's also important to keep in mind that there's an acyclic pattern to the graph that's shown on the screen right now, right? Project usages can get really dangerous when you start creating cycles. We call that cross-mounting, and I'm going to provide an example toward the end of the speech here that'll show you what avoiding cross-mounting can save you. So the foundations of this approach, right, are issued here on the screen, right? You can see in the bottom, there's a URL, right? SAIC produces a whole bunch of very useful open source freeware tools, which include a style guide that shows you, how we tailor SysML in order to develop system architecture models, right? That thing is reinforced by, again, a free and openly available validation suite. To the best of my knowledge, it's the only one that is free and openly available online that you can use with the Cameo's built-in rule-based engine to check your work, right? It executes the style validation rules against your models in order to tell whether or not you've complied with the style, right? And this improves quality and increases tempo and also helps to ensure uniformity of style across models being developed when that is desired. There's also a one-page process in there, at least that's what we nicknamed it, right? And it's similarly been published at the Nkosi International Symposium. There's the reference right there. And that actually shows all the steps necessary to apply this style in constructing a systems architecture model. And all of those things are really useful as a baseline from which to build upon so that you can put that systems of systems architecture layer on top, right? Our methodology looks at the world from three architectural perspectives: the behavioral, which defines the operational role of the system. You're talking use cases and actors, The goal there is to get the user's perspective down as quickly and efficiently as possible so that we can move over to technical engineering content, which brings us to the logical architecture. This is a problem space definition. While requirements and shall statements have served the industry well for a number of years, decades really, the complexity of development and the added pressures of time and schedule and budget are making it harder for shell statements alone to answer the mail with respect to what is the problem I'm trying to solve. So our methodology encourages the use of a variety of SysML views enumerated there in order to actually model out the problem. And then the physical architecture answers the problem, right? It is the solution space. It is the thing that realizes the need. Okay? So it's a slightly different definition for logical and physical maybe than a lot of people are used to, right? We're not talking about software, hardware here. We're talking really about problem versus solution. With these things in mind, right, you can see here which aspects of SysML in the quadrant run one, if you're familiar with Cartesian, which aspects of SysML are used across which architectures, right? And then just below that, you can see what's already been implemented versus what's future work. And I can tell you in our current release of the validation tool, we are supporting structural and primarily logical, though there's nothing preventing you from using it for physical architecture work. But in a very imminent release, we're going to put out a version 2.1 that will now support system of systems behavioral modeling as well. So this is, in just a month or so, maybe less, going to be expanded to include the other half of that SysML coin. So how does this work, right? Back to this layered chart right here. It all begins with the library, right? The common library sitting on the bottom is the location where the repository, the authoritative source of truth for all of the touch points between peer system models within the Federation, okay? So this is where we put signals in yellow, which are used to represent the content exchanged over interfaces, as well as interface blocks, and those represent the mechanism of exchange. So if I need to send a message, right, to you, that would be a signal, right? That's a high-level piece of content that gets exchanged. But if I am sending it to you over a TCP over IP over 1 gig Ethernet copper, right, mechanism, well, we would have an interface block to represent that medium of exchange, that mechanism. The purple externals represent any system that the system of systems interfaces with, but is not part of the system of systems, right? So it's a traditional external entity to the system of systems, right? And then the surrogates, they're the linchpin that prevents the cross-mounting I mentioned earlier. Within any given system model, right? System 1, let's say, for example, needs to interface with system 2 and system N. If we were to include those models within the system 1 model, right, we would immediately create a cycle within the graph, right? And again, as I mentioned earlier, the goal is acyclic graph, because otherwise you get a replication of elements within the tool. Now, why do we care? Well, we care because, Cameo 2019 has a sort of a threshold of around 1 million, 1.1 million elements within a model, and then the performance of the tool starts to bog down, okay? I'm sure that's improving with Cameo 2021 and 2022X, but there's always going to be a limit, right? And there's a nonlinear growth in element count when you start to include these cycles. So it's very important to keep everything nice and clean, keep your performance tip top so that everybody actually wants to use the model. The surrogates are used in place of the system blocks within adjacent systems models. So that'll be a little bit more clear on the next slide. But when you're forming a surrogate, what you actually do is you pull the surrogate for system 1 into the system 1 model. And then you create these 3 realization relationships, right? 3 sets of realization relationships, I should say. The first one is just a simple realization from the system 1 block to the surrogate external block, right? That just creates the initial connection. So the model, again, the underlying model understands that these 2 pieces of data are related, right? The second set is to connect each port within the system 1 block to the equivalent port of the surrogate block, right? And then the last step is connect each top-level operation of the system block to the equivalent operation of the surrogate block. With those relationships in place, right, our automated validation rules can check for missing ports and missing interfaces, mistyped ports, mismatched conjugations, And in fact, will allow those ports and operations to be used, right, in adjacent system models in order for those developers to tell their stories. Once everybody does that, we can start to concern ourselves with a system of systems level. So you can see here, I have a system of systems level model across the top, and then two constituent system models below it. In this particular example, system 1 interfaces with system 2. Fairly straightforward, passing signal A over these two proxy ports. That interface is also shown in these two constituent system models, instead leveraging the respective surrogates. So how do we make sure that all three versions of the interface match? It's very easy for human beings to allow these things to diverge, right? And then you've got a system of systems model that says one thing and a system 1 model that says another, and system 2 is off doing his own thing, and none of it makes any sense. What we do is we create a realization relationship between the connector of the system of systems model and the connectors of the constituent system models for the equivalent interfaces. Once these two realizations are in place, right, our validation rules can be run in order to automatically check for missing signals, excess signals, missing interfaces, basically ensuring that all three representations of the same interface match exactly. So everybody is working from the same definition of truth. And that the same thing works for our system of systems externals. There's simply just one less realization required. So I mentioned earlier that there's very often a need for protecting data, and plenty of times different teams develop differently. They use SysML differently, and we call that a style noncompliance or style divergence, right? You know, I really like our style. I really like it. I strongly encourage people to take a look at it and consider it. But, you know, there's all sorts of reasons why existing system models might be in a different style, like they were developed in the past before the common style was agreed to. So in this graphic, you can see all of the teal or bluish models are of a common style, right? Except for system N. System N is of a purple style. It's just different, right? It's not wrong, it's not right, it just is. So one solution is to spend a ton of money and time to refactor a complicated system N model to align the style. That's not realistic a lot of the times. I mean, people just can't throw money infinitely when there's perfectly good standalone system models out there. So what we introduce is something that we call the micro model. And the intention of that name is to express how small it is, right? It's a very limited set of content. The micro model basically acts as an adapter, allowing the system N model to indirectly participate in the federation, right? And well, what needs to be in the micro model? Well, it's pretty straightforward. It's the top level content that allows system N to be represented as a black box, right? We need to see a block. We need to see the ports, right? For the gazintas and gazoutas. And we need to have the top level operations available. Once those things are in the micro model, right, and leveraging common library content, right, it can participate just like any other system within the system of systems level description. The danger here comes in this purple line, right, in that how do you make sure that the system N authoritative source of truth purple model, right, is always accurately reflected in the micro model? Well, that's up to you, right? An approach would be to use engineering inspection to assign a human to make sure that they match. But in my experience, humans often make mistakes, they get busy, they get reassigned, right? A more robust and slightly more upfront cost would be to create a custom validation suite that's specifically to ensure that the content as modeled within the system N model, right, is matched by the content within its equivalent micro model. And then you could just run that validation suite each time in order to check. The reason why this has to be custom is because it's heavily dependent on the particular style of this purple system N model, right? What's nice about this approach too is let's just pretend for a minute that everybody was in the same style, including the purple system N. But the system N model had intellectual property in it, right? Or classified data that exists in some other network. By providing a black box micro model representation that is style aligned to the federation, you can obscure, right, the details below that, right? You don't get any white box content by creating this. And so none of that intellectual property is exposed. It's just the external interfaces and top-level functions. And in fact, you can choose to elide even top-level functions or top-level interfaces from this micro model, and it'll pass validation. So that's a lot of theory, and I know that's a lot of ideas all at once. So let's try and take a look at scenarios in which we've applied this. So I've personally applied this for a US Navy system of systems effort, and you can see the after effect shown off there to the graphic. Okay. What I did was I came in to a group that already had kind of a federation in place, but without a real clear methodology and approach to doing so. And what I did was I applied this one, and I made two big changes. I applied this layered approach that you've seen again and again in these slides. And I've also introduced the concept of a traceability model, which pulled this US Navy reference model out of the direct path of reuse, right, of project usages, and kind of segregated it so that these traceability models are taking the performance hit for all these elements. Those two changes reduced the overall size of this federation model from above 1.1 million elements down to less than 300,000 elements. So remember when I said earlier that there's a nonlinear growth when you get cycles within these trees? I'm really not kidding. That's an order of magnitude difference, right? And again, this was done in a 2019 Cameo tool. And so the performance was just screaming at this point. And people were abandoning the use of the MBSE tool because it was just too painful. Mouse clicks were taking 20 seconds a pop. You know, that's not realistic to be able to do development. But once we move to this new configuration, this new pattern, right, of less than 300,000 elements being present, people were able to go in here and make modifications as needed, major performance improvements. So this is another program where we applied this for the US Space Force. In this case, you can see micro models being introduced. So we have a ground segment model, and we had two different flavors of space segments, right? Constellation 1 and Constellation 2. So Constellation 1 was done while this Federation effort was getting underway, and so it was already style aligned. But the ground segment model was developed 2 years prior, and the space segment model was being developed by a contractor who just simply couldn't afford to change the work that they had done so far into being style aligned compliant. So we introduced the micro models, right, and allowed them to participate, and we're still able to do the system of systems level description up here at the top, right, based off of this common library data, right, managing the touch points between these three models, right. And then in this case, we had a reference model as well, but this one was not so large or so intrusive that it was affecting performance. And so you can see we ended up placing it in a lower level of the stack as compared to the previous one. So this is micro model in practice. Here's another example. This is also for a space-based system, but I can't discuss which customer it is, right? It's a classified program. And in this case, we had two developers who were highly invested in their existing content, but the government had a really strong desire to see them come together in a system of systems model, right? In a federation context. And there was a desire also to make sure that all of the stakeholders involved didn't have to learn, two or three really different styles of model, right? A block always meant one thing, a signal always meant one thing. With those requirements in hand, the compromise position we came to was, the individual constituent peer system models were going to be internally style inconsistent, as strange as that sounds. What the goal was is to make their top level content, right? Their system block, their external interfaces, their top level functions, all within the Federation style. And then as you dive down into the lower levels of design and even detailed design, because these models were quite robust and used for a long period of the system's lifecycle, what we get into was, style divergence. But that was a compromise that everybody was willing to accept, because in this case, they were really interested in seeing, again, the interplay between these systems and externals. So what we've been tinkering with recently in again, another classified program where we have system of systems model contract being kicked off much earlier than actual system development models. And these folks aren't even available necessarily to participate in the conversation. So we're trying a slightly different approach, right? Because that delay in contractor kickoff and a need to start to figure out the system of systems behavior, we've introduced this concept of a system of surrogates, okay? So again, it's the surrogates that I talked about before, but in this case, this portion of the model is used to kind of early on figure out at a top level what those systems are doing without concerning ourselves with their internal composition, their internal designs, right? Getting ourselves into a position where the surrogates can then be handed off to the individual developers, right? So that they're basically templates, and then the developers can match them, right? Can build out the designs to align to them. And when they need to, provide feedback that corrects the system of systems level. So this is kind of a different approach, but the key again here is that this is connected, right? We are designing the surrogates, AKA the system black boxes, and placing them into the common library such that they are the starting point for the development of the constituent system models that then later will come together in their fully formed, fully decomposable system of systems model. Okay, so future working conclusions. One thing that came up very early on that was absolutely critical was model curation and configuration management. Managing each model within this federation and ensuring that it is consistent to the style and approach that it's pursuing, to ensure that all of the pieces are available within the library, within the peer system model, such that it may be used in the system of systems model, is a daunting task. And then, let's say we have a draft of the architecture. Well, what happens when it needs to change? Inevitably, they always need to change. So it really necessitates a unique process, and this might be program specific, right? To figure out how you're going to manage change, how you're going to manage the configurations, how you're going to distribute data and work together. Get discrimination between the logical and the physical architectures. Well, the current capability can be used for either, right? But there's not any existing rules within the federation subset of validation rules to ensure that logical is staying in the logical space and physical staying in the physical space, right? And so there's an opportunity there maybe to reconsider some protections at that higher level that we're exploring. Right? SysML behavior. I mentioned actually that, version 2.1 is coming out. I personally helped write the rules for that. The validation rules that'll be used in order to make sure that the operations on system blocks align to the operations on surrogate blocks, such that they can be used within peer system models to describe the behavior, right, of external systems, or peer systems, I should say, as well as the behavior of the system of systems overall. Again, this should be coming out imminently, right? And then those individual operations, which are the currency by which we reflect functions of a system, can be used, activity diagrams, sequence diagrams, state machines, in accordance with the, SAIC system architecture model approach. That really provides a lot of power and a lot of flexibility in describing the behavior, what the system and its constituent systems do. The behavioral architecture, again, this is use cases and activity diagrams, if you remember back. We have not spent a ton of energy in this space to date, trying to figure out, well, do system use cases roll up to system of systems ones? It seems intuitive that they might, but I think there's an opportunity to explore that a little bit more with an emphasis on keeping it lightweight, right? One of the biggest problems that I have with use cases is you get 5 people in a room and ask them their opinions about use cases, and you get at least 10 responses, right? It's the first thing anyone ever teaches in an MBSE course, UML, SysML, doesn't matter. And therefore, almost everybody has a strong opinion about it. My opinion is that use cases are really just buckets. They're buckets to hold functionality in the context of a story. And the quicker I can get over to elaborating them through, for example, an activity diagram that shows actual system behaviors and actual externals doing something, the better, right? The more includes and extends and all of those kinds of relationships while supported by the language, the more, I guess, time you could potentially waste and money you can throw down the hole instead of moving over and focusing on the actual functional architecture. So I just showed a bunch of examples of this being applied, and most of them had tailoring, right? I mean, every program is unique. Every customer has their own unique set of needs. This is not meant to be out of the box, 100% perfect solution. This is meant to allow you to, an 80% solution, to allow you to tailor it as needed. As I mentioned, again, the validation suite we produce that supports the style and then this federation method, each one of those rules are tailorable. You can edit them yourself in your own development model if you're skilled with structured expressions and meta-chain-based navigation within Cameo. You can toggle them off and toggle them back on. I generally recommend getting really familiar with the baseline capability, or even reaching out to us at SAIC in order to understand why rules are written the way they are and how they work before doing that, because there is a reason, right? We've applied this methodology on dozens of systems development efforts ourselves. We track sort of who downloads the material, and we've seen over 300 different organizations applying it as well, and also providing some of them feedback. And so there's a reason for each rule that's in place and each step in the one-page process, for example. So I highly recommend really thinking that through before engaging in heavy tailoring, but it is available as you need.
May I mention that you support Rhapsody too? Because I'm not advertising it, but I just wanted to mention it.
No, that's a really good point, and I tend to forget about that because I do almost all of my development in Cameo these days. But that is absolutely true. We are not married to any particular tool, and so we make a consistent effort to whatever gets built in Cameo within 6 months to a year gets released in Rhapsody as well, right after the fact. It requires a little bit of specialized work because the way you create a validation suite in Rhapsody is a little different. It's a little bit more coding intensive. And of course the structure, right? An MD-zip file and MD-XML file is a little bit flatter than the Rhapsody files that are used. And so we have to navigate things a little bit differently. But that's a really good point, and I'm glad you brought it up. If your program is using Rhapsody, you can still do this kind of work, right? You just use that version of our tool. All right, I think I'm a little bit ahead of schedule, but that probably means I blew past some concepts a little quicker than I should have. So my name is Chris, and I want to open the floor to questions.
Yes, may I take the honor to raise the first question? Could you go back to page 11?
Absolutely. 11.
11.
Yes.
It's 11. It's 11. But you could imagine to have a system of systems model based on surrogates, or because this is the way I would think about it, saying, okay, that's business level. It's enough to have the surrogates, just to have the black boxes, because I'm just interested in the exchanges.
Yeah, that's true. I mean, a lot of system of systems level stakeholders are only interested in that top level information, but not all of them, right?
Okay.
So if you think about an acquisition program office, right? They have a vested interest in making sure that their sensor connects to their C2, connects to their weapon correctly. But they are also purchasing, on behalf of the government, on behalf of the military, these individual systems. And so they have a real need to see inside the box in order to provide the governance that they're supposed to be providing to the individual developers.
To support the acquiring effort, yes.
Yes.
Okay. Yeah.
Absolutely. Also,
but first step would be to have the surrogates on the system level, and then to create the white boxes.
Right, which is that's the concept of the system of surrogates.
Yeah, you showed it later in a later page already. Yeah. Okay.
Yeah. But another really important point here, though, is if I just had a system of systems model by itself, right, that showed the interplay between these systems, but wasn't based on reuse of content at these constituent system levels and the library below it, then there's no digital engineering mechanism to ensure that they align, right? In this case, we can enforce that through automated validation.
Okay, so let's have a look at the question and answer. just as I mentioned or promised, you can start from top or pick anything you are interested to answer. Just open the. Yeah.
Okay. So I see a question here on slide 7. Couldn't your system of systems model be created using?
Yeah, just mention the name as the participant.
Yes.
It's easier to follow things. Yeah, it's Sam. So Sam
yeah,
answer. Sorry.
It's Sam Biller. Yeah, I'll do my best to pronounce names. Can you use UAF to do the system of systems model is the fundamental question. Sure. I mean, you can. You can make UAF the style of the system of systems model. You can make UAF the style, I suppose, of the entire federation. But you run into some of these problems here again, which is, well, 200 plus unique customizations to teach everybody on top of teaching them what SysML is in the first place. And then I'm not sure that you actually can, now that I think about it, take, like a system block in SysML and use it as a resource block in UAF without applying stereotypes at these lower levels. So I think it just introduces complexity without necessarily solving a problem. Hopefully that helps your question.
James Martin will show a paper about linking UAF and SysML on the INCOSE conference in Honolulu in June,
yes,
addressing exactly this problem. I recommend to have a look at his paper.
Yes, James Martin and I like to duel a lot.
Yeah.
Alexander Turkanov asks, behavioral architecture seems a bit a new term for me. What's the difference from a viewpoint? Yeah, so that's a good question. Behavioral architecture, again, I want to emphasize from our perspective, diagrams are not really the currency of the realm. They're not the most important thing, right? The behavioral architecture would represent a set of artifacts based in data created in the underlying relational database. But those artifacts are often tables and matrices. I mean, I think I even have some silly little eye chart graphics right here, as well as diagrams like use case diagrams. So there's going to be a number of different views in order to build up that viewpoint, if you will, I suppose. But it is analogous, I suppose, to a viewpoint, right? The idea, though, is that you've got a set of content, particular kinds of elements within SysML that are used in order to express the operational role of the system. So in that sense, there's some similarity. Demi Altman asks, why was the realization relationship selected? To my knowledge, this does not automatically keep two sets of elements in sync. Yeah, that's true. It does not automatically do it. There is no particular reason that realization was selected besides it seemed like the right spirit and intent. However, we did very intentionally use a, quote, dependency-based relationship. So another way to say that is a dotted line relationship in order to satisfy this. We need to use one and only one, right? So that we can automate it through validation, right? It's the element synchronization, right? Making sure that there's no missing ports, missing interfaces, missing conjugations, missing signals. That isn't realized just by using the realization. It's by creating the realization and then running our automated validation rules. Can you check for those things? So we're piggybacking on that. And we just as easily could have picked any dotted line relationship to do the job, but we chose realization. Okay, so, Chandersekar asks, on slide 15, were the two models developed using two methods like OOSEM or Arcadia? Slide 15. No, they were not. The methods used by these two contractors, and neither one of them were SEIC. These were independent OEMs. Their methods were homegrown, hand-rolled approaches. Richard Smith asks, as well as idential interfaces between System 1 and System 2, it is necessary for the response of System 2 in its surrogate to be identical to the response of the real System 2. This requires more than checking. How do you ensure this? Well, I guess I'm not entirely following the question, but the cartoonish example here only shows signal A, right, being exchanged as an item flow over this connector. In reality, our system models have, dozens, if not hundreds, of exchanges bidirectionally. And once you create these realization relationships from the system of systems model down to the constituent system models, it'll check to make sure consistency across the board. It's not intended to check for like synchronous response mechanisms, right? Like there's nothing here that's going to make sure that signal A always results in a signal, or signal alpha always results in a signal beta coming back. That's just not the problem we were trying to solve. Danilo de Martini. Have you ever experienced this method with different tools that is not Cameo, e.g. Enterprise Architect, IBM Rhapsody? No. No, we haven't. So I participated in the original development of this approach, which was exclusively in Cameo, and we've had people porting it into Rhapsody, but those are the only two tools that we've used in order to do this. This approach is a homogeneous federation, right? When you start getting into tool diversity, that's a heterogeneous federation. You've expanded into a more digital thread-like topic, I think, than what I'm trying to tackle here. There's nothing to prevent you from that, but I think you need to start getting into much more advanced tools to exchange and convert data, data digesters. We look at product lifecycle management tools like Era's Innovator in order to help us do that, move from Rhapsody to Cameo to Sparks to whatever, and then connecting in other kinds of models, but that's just beyond the scope of what I was trying to tackle here.
Yeah, and I think that such approach would require the support of the tool vendors, and I don't see this support.
That's true, or you have to hand roll your own connectors. And it's a challenge. Yeah, it's a challenge. Shanderskar, I'm just going to stop there again, asks, in slide 16, are surrogates and micromodel interface complex? How the interfaces were developed means language. Okay, let's go down to slide 16. Are the surrogate and micromodel interfaces complex? Well, there's no micromodels shown on this particular slide. I would say that the interface complexity is not driven by necessarily the nature of the modeling techniques shown here. It's driven by the complexity of the systems. And in my 15 some years of experience, we are moving to software-defined, hardware-enabled types of systems. And software interfaces, the complexity is the limit for the nature of the data being exchanged. Marcus asks, what about responsibility within the common library as developing surrogate models? If several people are working onto the common library, how to manage the responsibility? Absolutely. That is such a good point that it was essentially my first bullet on future work and conclusions. But let's come up here and take a look at the library, right? The library model has all this good stuff in it. And every individual signal in here at least is something 2 or 3 people care about, right? Same thing with interface blocks, same thing with surrogates. So it really requires a curation effort, a distinct intentional effort to manage this stuff. And if you're not employing configuration management and change control processes in order to cultivate this common repository of reusable content by each organization, then you're doomed to failure. Right? So you're absolutely right. There is an Achilles heel here in the sense of being negligent of the library and of its curation will end in failure.
But Chris, you introduced a specific role in the federation process. Isn't it a federation manager?
Well, that's a great question. So on this program, we have an individual who is not really responsible for this work necessarily, assigned to manage the content of this. And he needs to work with everybody above him in the stack, but he is a distinct person.
Yeah.
On this effort, the system of systems model and the library model are owned and managed by the same two people, right? It's a small team of 2 full-time employees and a couple of support folks. So it really is a decision for your program as to how you want to do business.
No, I don't like the term it has to be done. I like the term the role has to do it. That's the point.
Yes.
So somebody has to be appointed to do it. Okay.
Absolutely. Absolutely. Anvesh Midi asks, when 2 engineers work on the same model in parallel or separate branch, how does SysML provide merge options? Is this manual work? That's a good question. I haven't really talked about that on these slides. Cameo and tools like it do provide a project merge feature. We overwhelmingly avoid it at all costs because it inevitably leads to a lot of issues, a lot of trouble. We do our development for every model within the trunk of Teamwork Cloud, and we use the lock mechanisms to check things out and check things back in. And while that might to some folks seem like a burden, right? The reality is it is much easier to do concurrent development within a model versus simultaneous, then have to merge it later. The across models problem, right? Developing in parallel across models. Well, we're not trying to solve that until we get to the validation step, right? Once the realizations are in place, particularly these ones, and we run validation, we get a report of errors where things didn't match and align, and then those need to be burned down as work tickets or trouble tickets, depending on your respective process. Brian Sheehan, can you please share Chris's contact info? Yeah, sure. That's easy. It's in these slides. There's my email right there. This is the URL to the validation tool that has a lot of this capability, open source freeware. Feel free to reach out to me. And I'm sure these slides will be posted and whatnot. So
yes, in LinkedIn and on the Incosi website. Yes, for sure.
Yeah.
We have to speed out a little bit up because we have 14 questions left and 9 minutes to go. So
okay. Sam Biller, is the surrogate just a black box model? Yes. Right. If you start to put content in below it, you're basically replicating the system model content, and that's not desirable, right? The surrogate is just there to be a stub for peer models to avoid the cross mounting. Tyler Jackson asks, would the surrogates concept extend to the behavioral model? That's a great question. I haven't explored it. It's possible, but to be honest, because I prefer to get out of use case space as quickly as possible, so that I can articulate, users' needs, external actor, external system needs through their interfaces and the functionality and composition of the system within behavioral and structural views, as opposed to other behavioral and structural views, as opposed to use cases. I tend to get out of there as quickly as possible, but perhaps there's a surrogate role there. Austin Renwick, do I understand correctly that realization relationship is what is being leveraged by our validation suite to ensure that when a change is made to a system, it gets updated on the surrogate? Yeah, in part. Yep, that's part of it. There's a subset of the validation rules that piggyback on these 3 flavors of realization that make sure the surrogate matches the system. These realizations make sure that the interfaces are consistently represented across the various models. So we're solving 2 problems with realization-based validation. Samantha Infeld asks, can you clarify the difference between using a surrogate element versus using the element from its home location through a project usage? Is it an additional relation of realization? We use surrogates. Actually, I'm going to stay on this slide. So we use surrogates to prevent that cross-mounting, to prevent that acyclic pattern within the graph, which balloons the number of elements and ultimately does bog down performance because it's a nonlinear growth problem. You can see here, surrogate 2 is pulled and used within the system 1 model instead of pulling the system 2 block. If we pulled the system 2 block in here, we would end up having to create that circular project usage. right? So that's their purpose. That's the idea. We probably have time for one or two more.
Surrogate is a kind of library you pull.
Yes,
isn't it?
the surrogates come out of the library.
Yeah.
Demi Altman, I've experienced that the level of abstraction for interfaces differs across models. Some have higher level logical interfaces and some go all the way down to pins. Have you seen this between system of systems physical architectures, and how have you addressed it? Absolutely. We'll go with the easier answer first. So our methodology doesn't necessarily encourage it, but it fully supports the idea of doing nested ports, a proxy port on a proxy port. And we can use that with the affiliated connectors and whatnot in order to map the exchange of information. It's generally data over like custom connectors, custom cabling, for example, at the pin level, right? That's really handy. Now, if one system model is doing that here and all the others aren't, you have a really fundamental style divergence problem, right? And you have to start talking about a micromodel solution, right? Where, okay, it's fantastic that system N did that detailed, connector pin level decomposition because they needed it, but that's not really going to jive with everybody else within the larger system of systems. And so we need to bring that up a level and abstract it a little bit such that we can, talk about things at a system of systems level and connect them within the federation. Marcus Andres asks, how do you bring the system model and the surrogate model in sync? We use validation, right? Like I said, we have a couple of a subset of our validation rules executed against the system one model. We'll check, leveraging these realizations, that its surrogate is in alignment. And it'll throw errors if you have like an operation down here that isn't present on the system one block, or if the surrogate has an extra port that isn't present on the system one block, it will throw an error and ask you to correct that. Ashley Gruwell asks, is there a reason you didn't use a generalization between the surrogate and the system to ensure compliance? Yeah, we sometimes want to elide information, right? You might have classified operations or proprietary interfaces or something along those lines. And if we just use a generalization inheritance-based pattern, then we have to do override the pass down, and it becomes just more complicated. By using the dotted line dependencies, we can kind of pick and choose in a very lightweight way, and then piggyback on that for validation. You stop me if we're running out of time.
I do so.
Yeah.
We have 4 minutes left.
Wilbur Gonsalves asks, if multiple companies and vendors were to use different tools like Federation and MBSE while working on a project best suited for their ease of use, how would it be tackled to get an end product? Would it affect the workflow and issue resolution process? So I think you're asking, what if system one was built in Cameo, system two is built in Rhapsody, and system N was built in Sparks or something like that? Well, now you've got a heterogeneous federation problem. Even though they're all SysML models, right? They're really not especially compatible. And you almost have to approach that problem, from my perspective, from the direction of a digital thread, right? So what we might do is connect a product lifecycle management tool like Eris Innovator or SEIC's Flavor Ready One and ingest, I don't have a graphic for this, but ingest the data from those various models and then use hand-rolled or customized connectors to pass them to whatever model from Eris you need. And that might allow you to share the data. You could also do this with analytical models, right? Like AFSIM or MATLAB or STK or something.
So let's call the last question. Running out of time.
Okay. Aaron DeMello, where does the cross-mounting term come from and why is it called that? That's a great question. I have no idea where the term cross-mounting comes from. I've always called it that, and other people around me have called it that. I picked it up from them. The idea is that if system 1 has a project usage to system 2 model, and system 2 model also has a project usage to system 1 model, they are cross-mounted. But I don't know where that definition comes from. And when you do that, right, all of these elements appear over here, and all of these elements return over here, and you get this nasty cycle that ends up having a lot of replication that's undesirable. It doesn't help you do anything, which is why we really emphasize the acyclic pattern within the graph. Okay, well, thank you very much for having me, and I really hope everyone, found some use in what I shared today.
I'm sure. It was my pleasure having you. Thanks for a great presentation. Thanks for a great presentation. Last words. Thank you for attending. We hope you enjoyed this talk. Good luck and goodbye. See you. Please send me the presentation. I will post it on LinkedIn and upload it to the website. And as soon the recording is available, I will send you a link. You can download it and use it on your own website if you like.
Excellent. Thank you.
Yeah.
Thanks everyone for attending.
Yeah. Bye-bye.